3.6 number 61 says, so there's a figure here that shows the average Fahrenheit temperature in Fairbanks, Alaska during a typical 365-day year. The equation that approximates the temperature on day X is this equation. On what day is the temperature increasing the fastest? So you don't need to know necessarily what the graph looks like. So this is the problem right here. So we want to know when it's increasing the fastest. So we're looking for the maximum of our derivative, because that's the greatest rate of change when it's increasing. So we have to find the derivative, but then we have to find the maximum of the derivative. So to find the maximum of the derivative, you have to find another derivative and set it equal to 0. Alright, so y prime, the 37 can float. Now the sine of u is just, the derivative would be the cosine of u. Derivative of 25 is 0. So cosine of u times the derivative of the inside. Well, the derivative of the inside, if you distribute that, it's just going to be 2 pi over 365. That's my first derivative. If I want to find the maximum of that, we're going to set that, we're going to find another derivative. So 37, the derivative of cosine is negative sine. So negative sine of u times the derivative of the inside, which again is 2 pi over 365. So now we're squaring it, and we want to find when that's 0. So this is just a constant, that's a constant. Really, the sine of something, if I know that the sine of x is 0, or the sine of anything is 0, the first time that sine is 0 is at 0. Like if I have the sine of 4x squared equals 0, then you could just set the inside equal to 0, because the sine of 0 is 0. So we could just set this inside equal to 0. Well, that's still a constant. So looks like the 101st day is when we have a maximum increase in temperature. Part B, how many degrees per day is the temperature increasing when it is increasing at its fastest? So we're looking for the rate of change at 101. So we just have to find y prime of 101. We plug it in to our derivative. So that's 0. That's 0. The cosine of 0 is 1. So this whole thing is 1. So it'd be 37 times 2 pi over 365. 37 times 2 pi divided by 365 gives me 0.637. So it'd be 0.637. We're in degrees per day then. Sorry, you probably didn't see all that.